All right, so this is number 21 on page 274. This is an example where we are given an angle in radians and asked to find sine, cosine, and tangent if they exist. Now, the key to this is to realize that what we're really doing is we're kind of finding the sides of a triangle, and I'm going to walk you through basically the entire process of how you would more or less derive this, although in the future you want to become more familiar with these, again going back to our plate that has all of these coordinates just kind of listed out there for us. But again, I want to have an example of us kind of going through the entire process on here. So this will be that example. Now, the first key is to first make sure that the angle we're working with is positive and between 0 and 2 pi. Okay, and in this case, 2 pi over 3 is, and in fact, a way that I get in the habit of writing it is this is 2/3 of pi. Okay, so basically we have 2 out of 3 pieces of pi. So if I were to look on here, I would know that I'm going to be 2/3 of the way over to pi. Now, drawing that, and again, this isn't going to be exactly to scale, but we're going to be somewhere right around here. Meaning that from here to here, we have traveled 2/3 pi. Now, one of the things that we're going to go ahead and do here is I'm going to create a triangle. Now, I'm creating this triangle based off of the unit circle. So I'm going to drop a perpendicular down here. Okay. And the reason I'm doing this is because if I create a triangle and I'm saying that this is on the unit circle, so every radius of that circle, kind of if I were to kind of do a quick sketch or a drawing, every radius is going to be r equals 1. So now I know the hypotenuse of my triangle. Okay. Okay. Now we're going to construct the other sides. Now to construct those other sides, what I'm going to have to do is use some of the triangle properties that we know, and I know that if from here to here is 2/3 of pi, well then the remainder, or this section right here, would just have to be pi over 3. Okay? Again, because if we take 2 pi, or 2/3 pi plus pi over 3, or 1/3 pi, we're going to get 1 whole pi. Now I know if this is pi over 3, okay, I'm a little more familiar, but I know that pi over 3 is equal to 60 degrees, which means that this angle up here would be pi over 6, or the equivalent of 30 degrees. And again, I don't necessarily recommend translating between the two or converting each time, but I know that degrees tend to be a little more, just a little more straightforward for most students. Okay, so here we have, this is 90 degrees. Now, without going into the exact properties, it's more of an algebra type problem. I know that if my hypotenuse is 1, okay, then the angle opposite of the 30-degree angle, or the pi over 6 angle, is going to be 1/2 of the hypotenuse. So if the hypotenuse here is 1, this is going to be 1/2. And since I'm in the second quadrant, I know that my x value here, or the amount I traveled to go from 0 over to the left, would be negative 1/2. Again, that's just stating this is 1/2. These points probably shouldn't be here. By the same relationship, I know that the side up here, okay, would have to be square root 3. Normally it's square root 3x, but since this is 1 instead of 2, and again I'm referring back to kind of the 30, 60, 90 relationship, okay, I know that this will in fact be square root of 3 over 2. Okay? Basically every side of that 30, 60, 90 triangle was just divided into 2. Now that I have these values, I want to go back and I want to basically take stock of what this means. Well, what this means is that if I want to go to this point up in the corner here, okay, well, that point there, I go negative 1/2 to the left. So negative 1/2 there to the left here. And then I'm going to go up square root 3 over 2. Now, the reason I'm writing it as a point is because for your plate, you eventually want to make sure that you have all of these coordinates here. And it makes it really easy to do these problems. And I'll do another example where I just use the plate. And that way we don't have to derive it every time, because we're going to notice that there are very similar patterns, or there's a pattern for all of these. So we don't actually need to memorize all 4 quadrants. All right. Now, based off this point, I knew that the negative 1/2 was my x, and the square root of 3 over 2 was my y. Now, if I look at this, what that means then is that I look, well, this side right here, the y side, is the opposite side. Now, the x side is the adjacent side. And as it turns out, that will always be true. So I'm going to write that up here, okay, that the adjacent side, okay, is always going to be our x value, and the opposite side is always going to be our y value. And then we can see here that our radius, or our hypotenuse, is always just going to be the radius. Well, fortunately, in this case, we made the radius 1, so it's going to make these pieces pretty easy. Now, based off of all of this, I can go through and I can actually very easily figure out my sine, cosine, and tangent values. Okay, so if I know that the opposite is just my y value, and the hypotenuse is just my radius, which is equal to 1, well, if this is equal to 1, then I know that sine of 2 pi over 3 is just going to be the y value for that point. So I look here, and I see that my y value is square root of 3 over 2. You can also just go straight from the definition of sine. The opposite is square root of 3 over 2, and we put that over the hypotenuse of 1, leaving us again with square root of 3 over 2. Now cosine, okay, well, in this case, well, I know that adjacent, okay, has to do with my x value. So adjacent is going to be x. The hypotenuse then will be r once again. But again, since I'm using a unit circle, I know that r is equal to 1. So I'll just have x. X over 1 equal to x. And I look here and I see that x in this case for this angle is negative 1/2. Now, if I move on to the very last one here, well, opposite is y, adjacent is x, therefore tangent is just equal to y over x. So I know that y is equal to square root of 3 over 2, and that x is equal to negative 1/2. Okay? And I'm going to use a little scratch work over here to do this. Well, that's the square root of 3 over 2 times, or I'm sorry, divided by, I'm getting a little ahead of myself, divided by negative 1 over 2. Well, I can rewrite that as the square root of 3 over 2 times negative 2 over 1. Those 2's will cancel out, and then we're just left with negative square root 3 over 1, or just the negative square root of 3 for our tangent. Now, there will be a second problem. It will be number 29, which will illustrate the same process without having to draw this graph each and every time.